replacing old broken keys.
Oh yeah. Well, at this point, you can still get literally probably a dime a dozen of those keys.
Yeah.
Oh yeah. But there are other machines other than the Apple II, which is very interesting to me because I collect terminals, and the terminal made in 1975. You never even find more parts for it.
Right. Well, these parts can be used directly, as you can tell. I mean, they're strong, but because of this type of plastic, they also work extremely well in investment capital. So you can do burnout straight to bronze. In fact, I'm not going to do that often. Are you going to use the key? Huh? Oh, probably. Really? Well, because the raft is stuck onto it. Ideally, it wouldn't break with the raft.
Oh, yeah, that's so good.
Yeah, it's not. They are one and the same.
But yeah, it's an example of the that's the quality I was thinking.
The edges came out nice. The top didn't. The top got kind of oozy.
Yeah, that's why.
Which wouldn't have happened if I had more. So I printed like 6 at once. Because then it could print one, skip to the next.
Oh yeah, that's a cool.
Yeah. How to continue that program.
Well then,
Because of stock.
Fine.
the next one, flat top, you can print upside down.
You think you can do that in the next 10 minutes?
I can make that part with a flat top in the next 10 minutes.
Yes. I will print it upside down.
Yeah.
It'll go a lot quicker too.
Now,
Yeah.
so I think you would. Well, let's say this is how it came out. You would sand it down. And make it
Yeah, ideally, what I'd do in all actuality, because that part is small, is I print 2 of them at once. And by printing 2 of them, so what happened at the top, the reason it's all kind of crappy like that is because the plastic is just hot. And it doesn't have a chance to cool before
Are you talking to me online right now?
kind of like trying to pile
Happen to be what?
Never mind, because you are preparing, so.
So by printing 2 of them, it gives it, when it's working on one side, it gives the other side a chance to cool down some, and then it can hop back over.
right.
And alternate between them.
Alright, I'm trying
This is pretty cool.
As far as I'm concerned, you can have that. I mean, it's
bigger than I
Well, you're
thought.
gonna
I guess that's the size you need for the pie.
Yeah, the pie goes in this way, and there has to be enough room for the HDMI or the composite to come through an adapter out the
Did you
back.
find adapters or did you make your own adapters?
I bought adapters.
Did you? Okay.
Yeah, Monoprice makes them a lot cheaper than I could.
Right.
it's
Yeah, that's the one thing. I don't think anybody wants to build cables.
I'll find out.
It's hard to find one that gives you enough clearance in there.
Yeah, because he's going to redesign that part to not have that plastic.
Do like an angle
Dish so I can print upside down.
Did the B plus mess you up at all? On your layout?
Because it has the dish, it has to go up into the
Oh
air.
no, I haven't done
Yeah,
anything
so
with the B
it's,
plus
I
yet.
haven't
it did a
seen
reasonably
that.
good job with the dish.
Yeah.
Still, like I said, a little fuzzy. But because it, I mean, put it like that, not like it would be on the bed, you can actually see underneath it.
Yeah. And that's
And
the plastic would be hot. It's extremely.
well, it doesn't go up. It goes just in a single layer at a time. So at some point, you're just trying to print to the air, and there's nothing underneath it.
Right.
So that's where the design really comes back into it. I could, except then there's the.
Oh, right. Then the inside would sit down.
Yep.
That hollow cavity.
So unfortunately, on that shape, there's not, for this kind of machine, there's not really a way to win.
But, okay, this can be printed because it just slowly goes in.
Just a couple of minutes.
They can-
So I'll
they can
start
jump
probably right at
from
1:15 when it's already good.
Yeah, use the time.
So
How long does this take? To print?
that, maybe 3 hours.
Okay, I thought it was all day.
Well, it just kind of kept going in a circle, just like spiraled all the way up.
Really cool.
Thank you.
Yes, and thank you for. I don't know how far you had to come to get here.
From Marion.
So from
Marion.
I don't know where that is.
I-35 at Johnson Road.
I don't know where it is. I'm from Raleigh, North Carolina, so
Oh.
coordinating remotely via Gmail has been probably the only
20
thing I could have
minutes.
done. Okay. Well, thank you for coming that distance, and thanks for offering up your Ultimaker. Thank you for the demo. I'm much obliged, and don't leave the room because I get the feeling that that machine might disappear if you do.
It's not going in. Nobody steals stuff here.
Nobody steals stuff from here? Really, you think? considering how much, valuable and rare.
First of all, you gotta be badged to get in and out of the building.
I spent maybe
The place is under
6
surveillance.
hours calibrating
Yeah.
it after
There's like
switching it.
500 domes and.
It was a kit, so I had the nice side of it was designed for me, but I
That's
still had to.
exactly.
Yeah,
The
yeah.
problem is like leveling the bed out.
Please don't do that again.
And after I got it calibrated, it's really just been rock solid. Like, I haven't had any issues with it.
Yeah, that's what I mean.
Yeah, I wanted to use it for water-soluble support material. My original idea, which is made out of effectively elder
How am I doing anything behind it?
and it has this nasty tendency being water-soluble to absorb moisture from the air. So now I have
Last night I replaced
about a
the
pound
last
of
feature
onions
from
in
that
this.
bucket
I
report.
left it out for a couple days.
Yeah.
So I have to figure out how to bake it in the
Well,
oven.
now it's just.
Because the problem with it is the melting temperature is about that of where water boils at. So it's real hard to heat it to drive the water out without melting the plastic itself.
I can hear it.
Oh, I've got a Rubbermaid tote at home for some of my larger schools, and the whole bottom is just lined with
It's one of those.
calcium.
Has it been working or have I been
I have no idea.
If you put this,
So he's redesigned the
I take it you had-
printing it out.
I take it you had somebody local come bring you
You're
from.
making
Yes.
robot noises.
His name is Brian. How do you pronounce your last name, Brian?
Betcher.
Betcher. Brian Betcher. Why do you ask?
Oh, just was curious. He didn't look like you.
Well, I gave him my name. I gave him my name tag, so if anybody
I
asks
am
why
going
he
to
was
attempt to
here,
stream
he
this
can
session.
pretend to be me.
Yeah.
Because I was running upstairs to get
But
stuff out of my
otherwise-
out of my room.
It really, like,
microphones
a lot of
in
people
here
seem to, they give it
Okay.
I'm not sure where.
almost a superhero status, like it'll replace everything. It won't, but I mean,
These are the
it
kind of
just
things I
solves
basically
some
want
of
to do
the
the same thing with printing for and make
It's
stuff.
It really just.
I want to make the prototypes of stuff that never existed.
Like I do.
Yeah,
do
oh, yeah,
injection
yeah, yeah.
prints, And that's probably 90% of their. Is somebody's like,
That,
you're gonna have injection molds made. Can you
and then
print
to
one?
make
So I can make sure my
Put that in your-
this
Sure.
Prototyping in short
Put that in your pocket.
that.
And I have another guy working
Clip
with
it.
right now to produce up to
Loop
about
this through
500 parts
around a button and let it hang.
of a
How about right there?
Yeah.
Or I can do that.
Yeah.
steel
It takes a
pipe.
little while to make them, so that basically you have to set it up and how do you do mass production?
Slide the knob all the way forward.
You got a bunch of 3D. You got a bunch of 3D printers all in a row.
Yeah.
That's the only way to do it.
Yeah, there's other things.
Do the gangs.
Other things we're trying to consider, like, can you put them on their sides so when the part's done, it'll fall off? That's a legitimate strategy. I mean,
But
it's.
I think that there's a certain amount of.
How's that, Tim?
Influence of gravity there. You're
Do you need
actually
levels?
Predicated on.
Floor score and 7 years ago.
Slide the.
In some
Slide
places,
the
yeah.
lever on the
It
thing.
depends on how big it is.
The parts end up with.
Oh, red light.
There's
Red light.
kind of
Make
this
sure it's all the way over.
thing, like it shows up in the bridges.
It doesn't look like it goes, but if you push it, it doesn't stop, it's
And
done.
it really is the vector of gravity.
It's
So-
got 3 detents, but it doesn't quite line up with the words.
That's why I had a problem with this part, because I had to print, so this is a keycap, top didn't print very good,
It's
but-
all the way back.
So do you need levels?
So they came out reasonably-
Or can you hear me okay?
It's on there.
Can everybody hear me okay in the back? Give me what?
What?
All right.
Out of session.
Yeah, talk about it.
All right. So I'm going to save this. Oh, shite.
We are live streaming, by the way. It's working.
Oh, great. So I should probably not curse.
Well, I mean, I'm going to post it in the IRC and the mailing list, so up to you. I mean, you're rep.
All right. Where do you want me to send this STL? Do you have an SD card I can put it
Ustream.tv/channel/ulterior modem. With ulterior modem.
I knew there was
All
an
right.
ulterior motive to this whole thing.
So for folks following along as we prep here, what I've just finished doing is making a modification to one of my 3D models, and I am sending it to Brian, who is my local helper, who had a 3D printer that could help demo stuff for today. And we have successfully printed a test of this this part that I'll show you later on, and he's going to do another one with some tweaks to it, and hopefully it'll be done by the time I finish talking and swing over to show you the part. So, so now I need to eject the disk with the file on it. Give Brian Betcher disk. All right, thank you, sir.
Experiment with it.
All right. So I think we've got a couple minutes before the official start time, so let people kind of filter in. And I will just give you guys my usual spiel before I make any presentation. If I hear your phone make a noise, you have to come up and do a chicken dance after the presentation.
What have you done now?
I'm sure someone else will show you how.
You guys know my little teapot.
That'll do. You can do my little teapot instead.
I think I'm on. It's not like I get around to finally putting it back on the radio. It was weeks later, and I wonder why nobody's called me, because I don't hear it, because I don't feel live right now.
So I flattened the bottom.
Sitting on the table, like, it falls off. Yeah.
Incredible.
Plausible deniability. Also, I set up a file server online on the network. It's black book, but right now it's not there because I accidentally yanked the cable. But yeah, I haven't gotten anything on there yet. If anybody wants to give me camera cards, I've got 3 terabytes of drive space. I can pile all of it. And anybody who wants to exchange or contribute, you can get stuff off of there as well. And
Well, it outputs.
I'd like to get as many, because I haven't
It
had a
just
chance to take very many pictures.
And it goes straight to the
Still
server.
pictures particularly. I'd like to get what I can from whoever.
Oh, so you write the
And anybody else who's doing video,
that your computer's free to write stuff.
I'd like to put together something that's got a few angles and whatnot throughout this. I'm actually getting an audio feed from here, and I had intended to set this up to give everybody line in, but then I realized we all don't have enough cables and whatever, but I really wanted to do it.
Tony in his natural habitat.
Anyhow, so I'm in 104 or 103, whatever it is. The first door right inside behind the RA.
Just upload it to archive.org.
When we're done.
Yeah, that's what I'm saying. When you're done,
Yes.
upload it to archive.org.
Yes.
There you go.
Upload it before you're done.
Well, we are live streaming, so if you want to just grab the stream, that's great. I think this will be my first live stream. Hello, world. All right, so I think everybody is ready to go.
So everybody, I'd like to introduce Charles Mangin with 3D Print Your Next Apple II. I'll also mention that he wrote a recent article on this topic for Juice.gs. Thanks, Charles.
Thank you. Thank you, Kansas Fest. And if I haven't talked to you individually over the course of the week, it's because I probably haven't asked you for help with my Hackfest entry yet. So I'm sure I'll be getting around to every one of you. Anyhow, so 3D printing. Just a quick survey of the room. Who knows what I mean when I say I 3D printed something? All right. How many of you know what it takes to create that something that then gets 3D printed? How many of you are interested in actually watching that happen? Okay, great.
You're in the right room.
So, interest is high. Okay, so let's start with confidence is high, yes. Let's start with a little history lesson. So, in the beginning, the machines that we're all used to were big, expensive, heavy things, took up half a room, were the size of a refrigerator or larger. They were proprietary, and they had to have special operators, and you had to be specially trained. And you couldn't sort of interchangeably do what you could do on one machine on another machine. For instance, you may have had to, recompile, so to speak.
This thing's gonna kick off in about 2 minutes or less.
Okay. I'm just getting a warning that the fan's going to kick off and there's going to be something happening over here behind me. So those with ADD, take a breath, take an Adderall, you'll be fine. Then came along the pioneering hackers, the Wazes of the world. They wanted to make their own. So they had the technology and the know-how to make something smaller, make it personal to what their needs were, and replicate what the big machines were doing on a much smaller scale. And then they shared their knowledge with the hobbyists and early adopters. Again, the people that had the tools and know-how and spare time to follow in the footsteps of the pioneers. They didn't have any problem tinkering and hacking their own stuff together, taking it apart to fix it, a lot of the DIY spirit, so to speak. So those early adopters, some of them became entrepreneurs. And so they added to the technology the idea of design and making things more consumer friendly, and maybe adding a profit margin to be able to make some money from this hobby that they had. And also going from design for a person to download or to build at home to designing for manufacturers. So that's a very different process. And so that leads to things that are consumer friendly, that you can take out of the box, plug it in, turn it on, check out, that kind of thing. And so that process should sound familiar to the people in the room for an Apple II convention, because it's the kind of thing that went from the big IBM mainframes down to the computer that we all know and love, and then beyond. So we went from big bulky proprietary boxes to an Apple II on everyone's desk. Are we there yet? No. But we have gone from machines like this, where it required a special operator, proprietary, big expensive machines, took a big investment from a big company to make, and they served customers on a industrial level, so to speak, down to this guy, which is this the one you were talking about, Vince, that reminded you of an iMac? No. Well, there are more like that. This is a desktop 3D printer. You can see the scale here. It doesn't take up much more room than a Mac Plus, and it's using a technology that outputs parts that, and I'll show you one later on, that are almost injection molding quality. They're smooth, they're dense, you can paint them, you can sand them, you can modify them. They don't break or fall apart, they don't dissolve in water or warp when it rains, that kind of thing. And this is something that I think you can get for about $1,000. I think this particular one may have started out on Kickstarter, or there were a zillion to choose from, so I can't remember the specs on this one specifically, but $1,000, $1,200 for a really good home desktop printer, much like an early Mac Plus. $1,500 or so gets you a really good home computer that you can take out of the box, turn on, and use. So we've gotten to that part, but it's still very early adopter phase. So you guys already know the answer to this based on the hands that I saw earlier. But I'll go over a couple of the terms that I might be throwing around, or that you might have heard or read online. And when I talk about some of the models that you're seeing, there's different technologies produce different results. So the first kind that is the most common, and what we're working with here today, is called FDM. That's actually, I think, a trademark term by Stratasys or something. So you might see it referred to as something else by the rest of the world, but FDM, and then there's SLS, and then there's SLA, and then there's DLP, and then there's jetting, material jetting, blah, blah, blah. But we're going to be looking at FDM for the most part, because that's the kind of printer that you'll get in the Apple II range of one on your desk, or somebody with one on their desk. Because it's an inexpensive machine, it doesn't require lasers or materials that cure under UV light that you have to keep out of the sun, or any kind of exotic materials, that kind of thing. And it works a lot like a glue gun might. So imagine a glue gun. You've got the glue stick, which is this filament up the top, and it goes into an extruder, or what's called the hot end, which is, imagine that, the hot end of the stick, and it melts, it comes out in a fine stream. What happens is, when it comes out of the stream, it immediately cools and becomes solid again, and the printer part of it is moving it around while it's doing that. So as it extrudes, it's building up a layer of material. And when it's done with a layer, it steps up and builds another layer. So you start from drawing something in 2D, stack it up on top, and eventually it becomes a 3D printed part. Is that clear for everybody? Cool. So that's the essentials of all of the technologies. You create a layer, stack up a layer, create a layer, stack up a layer. In this case, it's PLA.
I actually have a screw.
Okay, cool. So could you pass that around? Does anyone see what that is? The material is PLA, which is polylactic acid, something like that. It's basically a thermoplastic that melts at a reasonable temperature and then cools at room temperature. And PLA, if I'm not mistaken, will eventually biodegrade, is that right?
Yeah, in commercial or industrial composters.
Okay, in an industrial composting setting, so you can put it in with compost waste essentially if your local waste management does that. Other materials are ABS, which is the plastic that Legos are made out of. It's more durable, but it's harder to work with. And they've gotten to the point now where the incoming plastic can be huge range of colors. It doesn't have to be just white and then you paint it, or whatever the raw plastic is. They've got pigments and dyes and stuff that make a whole wide variety of colors. But so FDM is what we're watching happening right now. And what can you make with a 3D print? Or what can you 3D print? What can you make with it? So one of the coolest things I saw recently was a project online to customize clothes for Barbie that Mattel doesn't offer a suit of armor for Barbie, for instance. So if your Barbie wants to go to the Renaissance Festival or play World of Warcraft, or if you want to dress up Ken with big Viking helmet, these parts are all prototyped and printed, and you can see if you look at the photo, you can see a little bit of the texture, but they're all printed on a 3D printer, prototyped, and output to use directly on Barbie. They don't have to do much modifying other than linking it together like chainmail, and it's a done product. You can do. There's a whole effort. I'm sure Jason can probably tell you more about Jason Scott can tell you more about the preservation of physical objects as 3D scans. You've got statues in Rome that are crumbling under the acid rain, museums that are in war zones that have statues that are thousands of years old that may disappear or get toppled in the next regime change. And so there's efforts to preserve those as really high resolution 3D scans, and the result is something that you can then print out and have at home. So you could have an honest reproduction of, is that Athena? Artemis, Athena, one of those. Jason?
Museum in the Netherlands and everything in their archives making all of the prints descriptions.
Cool. So for those who didn't hear, Jason was saying that there's a museum in the Netherlands that is doing this for their whole collection and making the scans available for free that anyone can use unrestricted to modify and print their own.
Apparently, the crazies in Iraq bombed Jonah's tomb, so there you go.
Yeah. So if we'd had high-res 3D scans of the Buddhas in Afghanistan, we could potentially recreate them on a miniature scale in plastic, but also once you have that 3D scan, everyone's looking at the model here, who you can see is wearing a 3D printed high fashion dress. And all this is plastic that's been extruded and either glued together or in some cases not. It's actually just articulated in the print. And so it's flexible like a dress would be. And then this whole headpiece is 3D printed plastic. So when it comes to fashion and gadgets and gizmos and home art and things like that, we're not talking about mass production, we're talking about mass customization. So if in the case of the dress, it's kind of an extreme example, but imagine you had Imagine you wanted a dress that fit you and only you. You get yourself scanned. That gets turned into a model. Someone can then take that model and design a dress specifically for your form and output it on a printer, and then you have something that is custom made for you on, you know, a one-to-one scale. And that could probably never happen with a mass production scenario. You couldn't call up, you know, Hanes and say, I want one that fits exactly me. They're going to make the average size, whatever model, thank you, and they're going to make 10 million of them, and it's going to fit maybe 1% of the people that are actually that size. And if you're, you know, not exactly that, you have to modify it yourself, or you have to get it tailored or whatnot. Did you have a question in the back?
Oh, I just had a comment. Actually, I had Invisalign a couple years ago, and I think it's 3D printed, because when you look at it, you can see it's a similar idea.
Yeah. Yeah, you're one of the early adopters of this kind of technology were dentists making digital molds of your mouth and taking or making molds of your mouth and having those digitized, and then they send them somewhere and then get back dentures or Invisalign, retainer.
Crowns that exact match the two fits for me.
Exactly. Crowns that don't require any adjustment.
But in the Invisalign tool, when they straighten it, they have to somehow calculate, like, hey, my teeth are here and I want to be here.
Yeah.
So they calculate all the steps to really experience the one for the step.
Mm-hmm.
And that's kind of cool. And they showed me a computer model, so that's kind of what I guess they were doing.
Yeah. So with that, as she was saying, with that computer model of your mouth, they can then adjust it to straighten your teeth, for instance. Or if they know that you're getting a crown replaced, they can, you know, simulate where the dentist is going to have to, you know, add that or, you know, remove material or whatever. Okay, one more.
So I guess they may not be Invisalign, but they may be 3D printing the mold.
Right.
That they make the Invisalign in.
Yeah. Somewhere in the process. Yeah. Somewhere in the process, they're probably making the mold as a 3D resin part, or some of it might actually be the resin that goes in your mouth, but it's on. Yeah, it's you know it's hard to know whether that's FDA approved or not. But anyhow, so the so somewhere along the line, they're taking that mold, scanning it into a computer, outputting it on a printer, and then either making a mold for it or adjusting it or whatnot. So that's that's the mass customization aspect of it. And then one of the things that leads to is accessibility for people with variable handicaps. So this is a prosthetic hand that if you are missing your hand from here, I think, to, you know, basically a forearm amputation, you can print this hand. It has it's fully articulated fingers and thumb, and it's got a system of, I guess they're pulleys, inside it, that when you bend your wrist or bend your elbow, if that's what's articulated, it closes the hand. So it doesn't have any electronics, it doesn't have any, fancy nerve simulation stuff. So that's all like the Dean Kamen level stuff where it's $100,000 for an arm or more. This can be printed on a home printer in a day or so, and then you put it together, or you can order one that is based on a scan of your arm, and it'll come to you. And again, it's just a matter of opening and closing your hand, and that changes everything for somebody that didn't have a hand before. To get something with this level of detail and this level of articulation from a doctor's office, from your insurance, it just the nightmare of getting anything through your insurance. The cost is astronomical compared to something that maybe is, how much material would you say? Let's say it's half a pound of PLA. It's $20. $20 of material, the time on the printer, and then having the scan made of your arm, or even just customizing it yourself with software. So again, mass customization. Everybody that has a wheelchair may have a different set of wheels on it, different set of challenges that they face, whether they have to go upstairs or over curbs. These are some 3D printed plastic ramps that you can just, essentially they collapse, and he puts them in his backpack. When he gets to somewhere where his wheelchair won't go over the bump, he puts them down, rolls over them. I don't know how he gets them back, but maybe he has a friend. Anyhow, and then you get into stuff like this, gadgets for your home that, if you wanted a better chip clip, somebody's designed one. Or a toothbrush holder that the ones at Walmart only hold 3, and you've got 4 toothbrushes. Or you want to be, just that much more of a geek and replace your light switches. You want to go over to the dark side and you want to indicate that. And then you get into replacing things that might be broken. So like the knobs on your faucet or on your washing machine, your toaster, whatever. There's real easy patterns to download or to send to an output bureau and make your own faucet knobs if there's one missing or broken, or if you have arthritis and you need a bigger one. You can get new tops for standard prescription bottles, tops that go on top of your water bottle that are more accessible for people with low grip strength or hard difficulty holding things in their hands. And this is all things that could be made on a mass scale, but there's not enough demand for someone like Pfizer to make 10 million of them, which is where their margins would come in and they'd make money on it. Or there has to be enough of a demand for, the red one for them to make the red one. But if you have the red color PLA and a friend with a printer, or a printer on your desk, or the website of someone that can output it, you can have your red knob for hot, blue for cold, big knob, little knob, replacement knob that looks exactly like the one in your 1957 Chevy that the radio knob broke off when your dad was angry at you that one time, whatever. Or if you want to, customize essentially a consumer part, a commodity part. There's, you can get basically this same thing made out of wood, made out of plastic, whatever. But you wanted one that's that color yellow, or you wanted one that's just a little bit bigger because you do grapefruit. Or you can 3D print a miniature Apple II if that floats your boat.
It does.
So consider the boat floated. So this, and this is where I'll digress slightly from the FDM process and talk a little bit about the process that I use is called SLA, and that is done by a company called Shapeways in New York. What I do is I create the 3D file for this, and I'll go through that process in just a couple minutes and show you the 3D file creation with some free tools. And if I have time, I might actually be able to send it to the printer and you can watch it happen. Anyway, so remember those big machines that I was talking about that take up the size of a school bus or whatever? Well, they're still around, and they make higher quality parts or higher quantity of parts at a time than you could do on a desktop printer. They have a giant print space that you could print that whole dress that I showed you, the full model of the dress all at once. Whereas the print beds on your home printer are going to be confined to the size of, maybe the biggest ones maybe the size of a basketball. So those guys are still around, and before you got a desktop computer, maybe you dialed into a time-sharing service, or you sent your code to a mainframe over phone lines, or not DSL, but whatever it was. Anyhow, you sent your code to be run by a computer far away, and you got the results back on a screen or a teletype or whatever. Same thing.